Today we're going to talk about the characteristics of a quadratic graph. So with this, first of all, what is a quadratic graph? A quadratic graph is just a parabola. And last week we looked at various types of parabolas in what we were doing. So with that, it comes from that standard form of the quadratic equation that we also talked about last week that we actually solved using factoring and using the quadratic equation. The standard form says y equals ax squared plus bx plus c, where again, a, b, and c are just numbers. And with that, we form a graph called a quadratic or a parabola when we graph it into our calculator. We're actually going to graph the equations the next class. This class, we're just going to look at the graphs. So when we look at these graphs, there's a couple things we have to identify and know. So today's a lot of vocabulary. So with that, the first thing I need to know is what type of parabolas am I looking at? What am I looking for? There's two types of parabolas we are going to study. We are going to study ones that make U's and ones that make N's, because all a parabola is a U-shaped curve. With it being a U, it could also be upside down and become an N. So all it is a U-shaped curve. With that, a couple things we need to know about our parabola. One, with our U-shaped curve, this one up here we say it opens up or upward. It opens upward, which then creates something we call a minimum of a graph. When I have a U, because it's going upward, this right here is going to be a minimum of my graph. Why? Because the minimum is the lowest point possible in the graph. The minimum. The minimum of anything is the lowest thing you can do. With that, when we'll talk about how equations get this maximum minimum later. But whenever our parabola opens upward, he's the very, very, very bottom. Also with our parabola, we can have what we call a maximum. He's going to open downward. If he opens downward, then that tippy top would be the maximum of our graph. So with the minimum and with the maximum of our graph, we find what we call the vertex of our graph, which we'll get to in a second. When these graphs are formed, we form something called an axis of symmetry. The axis of symmetry is the spot in the very, very center of the graph. It's a vertical line that divides our graph in half equally. That's where the symmetry comes from. If you think about symmetry back in, any other math level, let's just say we had a heart and it said, draw me a line of reflection. That's not a very good looking heart, but anyway, if I drew a line down the center, I could fold that heart over and it would match perfectly. So we called it a line of reflection. That's the same thing as symmetry. The axis of symmetry is a line of reflection in this parabola that if I folded my parabola over, he'd match perfectly. He's a vertical line. And he divides them completely in half. Kind of like if we drew an axis of symmetry through the center of your body from top to bottom. Your arms match and fold over. Your eyes match. They would just fold over and land on top of each other. You are a very symmetrical being. Your sides match. Same thing here with the axis of symmetry. When this U is created, this axis of symmetry will actually come right down the center of it through that highest point, which we call the vertex. We're getting there in a second. And I can fold over my graph and it matches perfectly. I can take this axis of symmetry and draw this line like this. It should fold over and make my graph look perfect. With the axis of symmetry, the big deal of my axis of symmetry is it's always an equation. Because just like I've just said now, it's a vertical line. Well, if you remember my vertical lines, they come from my VUX. A vertical line has an x equals equation. So whenever I identify this axis of symmetry, it's always going to say x equals and then something, some number, whatever the x is in the ordered pair it goes through. And you'll see that in our example in a second. So whatever the x of the ordered pair of this highest or lowest point is going to be my axis of symmetry, but it has to be an equation. That's the big deal. Otherwise, it'll mark it wrong on anything you're doing. The next vocabulary word we're going to talk about, there's a formula also to find the axis of symmetry, which we're not going to use today. We'll use maybe next class, but it comes from part of my quadratic formula. It's x equals, because remember, it makes the x line, negative b over 2a, where the a and the b come from that quadratic equation above. We'll talk more about that later in this unit. We actually find it using it mathematically. Right now we're just going to look at it on a graph, but it's important to know where these things come from. All right, we talked about the vertex. The vertex is the turning point of the parabola. That's where that maximum and minimum are created. When we came back up here, looking at our picture up here, right here, this minimum of my graph is my vertex. This maximum of this graph is my vertex. It is the turning point where the parabola starts to come down. If he's going up, it's where he starts to come down. When he's coming down, it's where he starts to go up. That's where the vertex is. In our minimum, which is down here, he is my lowest point. And he's always an ordered pair. When he's a maximum, he is my highest point. Again, he's an ordered pair. Always an ordered pair. All right, I got three more vocabulary words, and then we're going to move on to actually looking at some graphs and seeing what we need to do. Sorry. All right, our next vocabulary word, is our x-intercept. Our x-intercept has not changed since the beginning of the school year. He is still where it crosses the x-axis. When we have a parabola, if this is my x-axis, my parabola can sit in three different places. He's going to cross he can make a U like this, and he can cross the x-axis in two places and have two solutions. He can sit on my x-axis and have one x-intercept, or I can get all real fancy and he might sit up here and I have no x-intercepts. It's just where he crosses the x-axis. That is the x-intercept. When I get to this x-intercept, a bunch of things happen. The x-intercept's a big deal in my parabola. He's going to create what we call the solutions to the graph, which also tie back to the roots we talked about before. Solutions and the roots come back to what we did last class with the solving the quadratic equation, and factoring gave me solutions or roots. We had x equals 5 and negative 3. That's exactly where he crossed on the x-axis, at 5 and negative 3. They are the same thing. They're when we solved that equation with factoring, or we solved that quadratic equation, that's what these answers were. So we also call them solutions and roots. We also called them the zeros of the graph earlier this year, because the zero of the graph basically says the zero is where y equals 0, which is what my x-intercept is. So the zeros of the graph, remember, they got a ton of things going on. So with my zeros, I got a lot happening. The zeros of my graph is the zeros. It's the x-intercept. It is the roots. It is my solutions. And it's always the opposite of my factors when I'm solving it in the quadratic equation. A lot is going on with those zeros. And we'll find those later as well. Right now we're just going to look at parts of a graph. The zeros are a big deal. The zeros are the x-intercept. The difference is when I'm trying to find an x-intercept of a graph, my x-intercept is going to be an ordered pair. My zeros is just the number. If you remember from earlier this year, the zeros is just a number. The roots is just a number. The solutions is just a number. But the x-intercept is where he crosses on the graph, so he's an ordered pair. That's the only thing kind of different about that. But all four of these things come from the same math. All four of those things come from right here in my zeros. They are all the same thing. That's the big deal about the x-intercept. He's a big deal in this graph. And the last vocabulary word, and then we're going to start putting it all to use, is my y-intercept. If you recall, my y-intercept is where the graph crosses my y-axis. So wherever my graph crosses my y-axis, I get my y-intercept. That's pretty basic. And again, the y-intercept is an ordered pair. So now, let's look at two graphs and see what's going on here. So let's look at two different graphs. So first, let's look at a parabola that is going upward. Hold on. No. So let's look at this graph right here, number 6. I don't want to look at the bottom here. Let's just look at the graph. So first on this graph here, I want to identify certain things that we've talked about. So the first thing I want to know, is this graph a maximum or a minimum? Well, we said the U-shaped graph that made the happy face was our minimum. So this graph here is a minimum. So now, a couple things I want to know about my graph. I need to know, one, I need to know all this stuff down here. I'm just trying to hide all this other junk I don't want you to see. Sorry. There, I don't have to hide it now. I want to know a couple things about my graph. I want to know, one, there's my paper. Okay, sorry. I want to know the vertex of the graph, which comes from my axis, which also comes from my minimum. I want to know the axis of symmetry of my graph. I want to know the x-intercept of my graph, which is also going to lead into the zeros of my graph. And I want to know the y-intercept of my graph. That's a lot of mess to know about my graph. So we already know that it's a minimum and makes a U. So with that now, looking at this graph right here, what is the minimum of my graph? So my vertex is going to fall right here. So with that, my vertex, and I'm sorry this is a bad example, but I needed it for something else. So with my vertex of my graph here, it's at -2.5, -2. That's the vertex of my graph. It's where that lowest point was on my graph. So now I want to know my axis of symmetry. It is that vertical line that goes right through that vertex. That is my axis of symmetry. So remember, he has to be an equation, x equals, and he's going to be the x in my vertex, negative 2.5 or negative 2.5. He has to be the equation x equals, though, or to mark it wrong. Now I need to know my x-intercepts. My x-intercepts is where I cross the x-axis. So I cross the x-axis here at negative 5, 0, and I cross the x-axis here at 0, 0. That's my x-intercept. It's where I cross my x-axis. Now I want my zeros of my graph. Well, my zeros of my graph are my x-intercepts. They are the same thing. So it's just negative 5 and 0. And because there's two answers, you would put them in set notation, although right now they're not going to be. If you plug them into Delta Math or into IXL, they won't have you plug them in to the set notation. They'll just have the two numbers. And then the y-intercept, which is actually why I chose this example because it had one, is where it crosses the y-axis. It happens to cross the y-axis in the same place it crossed the x-axis, so my y-intercept here is the same as that one piece of the x-intercept, but it is 0, 0. That's a lot of information to pull off of one graph. But it's all great information to pull off the one graph. Let's look at another graph. All right, so with this graph here, let's pull off that same information we just did. So let's pull off that same information. So the first thing I want to know, is he a maximum or a minimum? Excellent. He's a maximum. How do I know that? Is because this is the tippy-tippiest top of my graph. It's the max it can be. With that, I then know that my vertex comes from that maximum, and that is the highest point on my graph. So my vertex here is, awesome, negative 8, 4. So now I want to know the axis of symmetry. Remember, the axis of symmetry is the equation x equals. It comes from my vertex x, and it goes right down the center of that graph. It is my line of symmetry. That is my axis of symmetry. So in this case here, it's x equals negative 8. Now I want to go ahead and bring in my next thing, my x-intercept. Okay, my x-intercept is where do I cross the x-axis? Well, I cross here at negative 6, and I cross here at negative 10, so it's negative 10, 0, and negative 6, 0. Which then means the zeros of my graph are where I cross my x-intercept, so it's just negative 10 and negative 6. And again, IXL and Delta Math will not have you put it in the set notation. Now, this one right here, which is why I chose that other example, you can't tell where it crosses the y-axis, so we can't ask for a y-intercept. It will not ask you for a y-intercept unless it's physically crossing the y-axis right now. Later we can find it mathematically, but right now it'll be where you can see it crossing the graph. I hope these examples have helped you. Thank you for staying with me, and I appreciate it. You have an awesome day.